I am from EPRI, and we are a member of the Smart Manufacturing Leadership Coalition, and we enjoy this from every angle. And question today is, why should we really care about advanced manufacturing? What kind of business we all have in that? Yes, I know. So, much better? Okay. So 1 minute will be deducted from first of all, of course, it's another incarnation of what Professor Davies described as a entire environment regarding smart factory. Of course, we know that smart factory will have to be connected to smart grid somehow. And of course, if it's connection to smart grid, what kind of communication technologies, and how about cyber security? How about interoperability? It was a painful exercise for all of us at EPRI and NIST and others when we couldn't get traction on smart grid until we came up with interoperability requirement. So it's very important. And of course, what are the standards? Or maybe where are the standards missing? Because if we are talking about advanced manufacturing, we know that different vendors would like to provide equipment for this advanced manufacturing. And they will be rather reluctant to do something if there is no standard, because if there is no standard, why should I produce all these things? And then peeling that onion, of course, we need to look into what role distribution generation will play, what AC versus DC will be over there, regardless if it's going to come from the grid or outside of the grid, what is the power quality? And I will spend a little bit more time on this one. And of course, demand response, and then core of smart factory. Sensors, automation, electrotechnology, advanced controls, informatics, prognostics. That's, I would say, that universities, with due respect to both gentlemen, should really look into new curriculum for young engineers. It is not mechanical engineer, electrical engineer like myself, or chemical engineer, Jim. It is very, very robust engineering field for people to look at, okay? So, however, smart factory objective, we were talking about this. Smart grid to be completed, develop design specification for small and medium-sized smart factories. Remember, 80% of GDP today is done in small and medium factories in the United States. So we really need to remember that with due respect, GE, GM, and others were not going to save GDP, but these small manufacturers where, excuse me, majority of people are being employed. And of course, demonstrate new and smart control technologies. Today, when we are talking about advanced manufacturing, at least when I am meeting with different groups, people are saying, oh, 3D printing. Oh, we are going to have a 3D printing, and we are going to be smart. And of course, it is typical situation which we had years ago when everybody who was thinking about digital meters, they were saying, if we are going to employ digital meters, means we are going to have a smart grid implemented. And of course, we know that it was on a building block. The same is here. All this 3D printing is on the building block to get to advanced manufacturing. However, why people are talking about 3D printing? Because it's cool and jazzy. You really can show, here is bicycle manufacturers, they're making a couple of parts based on 3D printing. So if I am using 3D printing, I'm really ahead of everybody, and I am going to take front page on Wall Street Journal. Even close to Ireland, Bentley is using 3D printing for our thing. So it is cool, looks good. It really makes you feel that I am innovative because I am using 3D printing. But again, it is not what we are going to talk about. Because there are key research questions I would like to briefly address here. You know, how these loads, 3D printing, advanced welding, advanced lasers, are going to be different from power quality point of view. What are power qualities, sensitivities, and contributions? And what mitigation strategies will be required? Of course, you may say, Marek, these questions were asked 15 years ago when we were trying to develop, along with few electric utilities, standards for semiconductor industry. It was only one type of industry, and we developed SEMI F47, and right now it is the only power quality standard around the globe for semiconductor industry. Now, how these loads are going to look from PowerPoint, because every utility has distribution group and they are doing distribution planning. They really need to know what's coming online. How many new lines, bigger transformers are. That information is crucial. The same, of course, energy intensity, and I will show you a couple of things right away. So with this question, we did a lot of testing with America Makes organization, which is in Ohio, and they allow us to